Hello students, now we are going to learn about LCM. Okay, LCM, L for lowest, C for common, M for multiple. Okay, so LCM means lowest common multiple. Okay, here we will learn about three ways of finding LCM too. Okay, here first of all we discuss about first way one, that is by writing the multiples. Like for an example, if a question is like this, find the LCM of 4 and 6. First of all, in this method, okay, by writing the multiples, okay, we write the multiples of the given numbers 4 and 6. So multiples of 4, I am writing here M4. It represents for the multiples of 4. You know the multiples of 4, like from the multiplication table also you can take the help. 4 1s are 4, 4 2s are 8, 4 3s are 12, and so on. Like this we can write the multiples. Okay, we can write even more also. Similarly, we can write the multiples of 6, M6, 6 1s are 6, 6 2s are 12, and so on. Okay, you may think that how many multiples we have to write. Okay, good. We have to write the multiples in such a way that we can get at least one common multiple here and here, maybe more common multiples also. Common multiples means the multiples which are found in this set also. We can take it as a set, okay, and this set also. So if we see here and here, 6 is here but not here. Likewise 12 is found here also and here also. So this is the common multiple. We can say 12 is the common multiple of 4 and 6. Similarly, if we try to find out the common multiples, 18, let's check. It is not there. 24, yes, on both. So that this is also another common multiple. Similarly, we can find 36 also, and so on. We may find other more common multiples also. So that from above, okay, we can write the common multiples. What are the common multiples we found is, one is 12, another is 24, another is 36, and so on. We may find uncountable common multiples. Okay, but it is enough for us to find out the smallest common multiple among them. Like among these common multiples, okay, this is the smallest one or lowest one. So this is taken as lowest common multiple. Lowest common multiple is found here 12. Therefore we can say that LCM of the given numbers what were the numbers? 4 and 6. Okay, LCM is 12. This is the 12 is the smallest or lowest common multiple of the given numbers 4 and 6. We found 12 on both the sets of multiples, other also, but among them 12 is the smallest one or lowest one. Now let's see actually what is LCM. Lowest common multiple we know, but what we can see is 12 is the smallest number which is exactly divisible by 4 and 6. You can think of, can you tell me any other number which is smaller than 12 and exactly divisible by 4 and 6? No. So that is the benefit of finding LCM. It has practical application also. We will learn about practical uses and applications later on. Now we can see for the same numbers, okay, 4 and 6, we can use another way also to find out the LCM. The numbers were 4 and 6, like in this method, okay, we just factorize the given numbers, 2 2s are 4. Similarly, another number also we can factorize, 2 3s are 6. Okay, no need to again divide because we have already got the prime numbers. Therefore we can write 4 is equal to 2 multiply 2 as the factors of these prime numbers. Similarly, 6 can be written as the product of these two factors, 2 into 3. Okay, so now while finding the LCM, okay, LCM equal to, what we can take is, these are the common factors, that we write once, only one time, and there are no other common factors, but even these uncommon factors also are written. Okay, and we find out the product of these factors, 2 2s are 4 and 4 3s are 12. So this is the LCM of the given numbers 4 and 6. So let's compare this answer with the first method we did by writing the multiples. That time also we had got the same answer, 12, and from this way also we got the same answer. Now you may think that why is it necessary? Yes, all right. Very good. Multiple ways of solution for the single problem. It is really helpful in our daily life also. If we get any problem, we can have multiple ways of solution. That is one lesson of these different ways. Moreover, this way too can be a little bit easier than that of the first way if the numbers are a bit bigger, because if the numbers are bigger, it will be difficult to find the common multiples. We have to go on and go on writing the multiples. It may be difficult to us, and it takes a bit longer time also. And if in case of 3 numbers, what to do? Okay, don't worry. In case of 3 numbers here, we follow the same process. We take the common factors of all the given numbers and common factors of any 2 numbers, and again uncommon factors. But for that case, it will be easier to follow another way, that is division method. That is way 2, and way 2 was prime factorization method. Prime factorization method. And the way 3 is division method. In this method, okay, the given numbers, let's take the same as before, 4 and 6 we had taken. So with the same numbers, let's go. In this process, okay, in this method, we write the given numbers together and choose a smallest prime number which can divide both, or we may take the prime number which divides at least one, no problem. 2 2s are 4, like this, one by one individually we divide. 2 divides 4, 2 2s are 4. Again 2 divides 6. 2 3 is 6. Like we divide 2 to 4 na, 2 2 is 4. Yes, that quotient is written here. We divide by 2 by 2 to 6 na. 2 divides 6 na. 2 3 is 6. Okay, the same quotient we write here. And if we find a prime number which can divide at least two of the given numbers, then only we can divide, otherwise we can stop dividing. Or we may divide again by the prime number to at any one also, no problem. Like 2 again divides 2 1 ja. If it is not divisible, then we write this number as it is. Again we may divide by 3 as it is here, not divisible. Again 3 1 ja 3. Like this also we can go, or we can have stopped here only. In that case we multiply 2 2 and 3 we multiply, or from here also we can multiply these factors 2 2 and 3, 1 and 1 also. So that gives LCM of the given numbers. Now we are going to multiply this 2 and this 3 and this 1 and 1 again. So 2 2 is 4, 4 3 is 12, 1 is 12, again 1 is 12. That is the LCM of the given numbers. Okay, so this is the third way, that is called division method. And we can see by this method also we got the same result, 12. Way 3. In way 2 also the same result, and in way 1 also we can see the same result. This method, division method, can be more easier than the other methods, because even for the greater numbers also we can find out within the less time. So that let's see with another example. Let's take three numbers, 24, 36 and 48, and a question is to find the LCM. Imagine for a while, if you are going to find out the LCM by our first way, that was by writing the multiples of the given numbers, it would be very difficult to write the multiples, because you may get confusion to write the multiples of 24, 36 as well, and 48 as well. And how far we should be writing the multiples until we get the common multiples, no? So it may be a bit big burden to us, so that we can choose the third method, by division method, in which we write all the numbers together in such a format. We divide by the smallest prime number, maybe bigger also, no problem, but we always choose a number which divides at least two of the given numbers, or maybe single number also, no problem. Okay, we are taking a easy way. By just 2 it can divide na even numbers, so that 2 divides 24, like 2 divides 24. Yes, 2 ones are 2 and 0 remainder 2. Now this bring down 4, 2 2 is 4, 2 2 is 4, like this we divide, remainder is 0. And this division work is done mentally, and this quotient is written here as 2 12 times is 24. Similarly, we divide 36 by 2, and in the working side we can divide, and we write the quotient here. 2, like that of factorization also we can do, like 2 is dividing 36, 2 first divides 3, 2 1s are 2, there will be 1 remainder, and 1 and 6 will be 16. Now 2 divides 16, 2 8 just 16. Like this also we can find out, because in the factorization you have already learned it. To find out the quotient, 2 1 ja 2, and here will be like while dividing 2 1 ja 2, remainder is 1, and 6 comes down 16. Likewise here 2 1 ja 2, we can just imagine that we are subtracting 3 minus 2. Okay, that gives 1 remainder, and like here, and 16 is here, it will be 16 there, like here, just we can imagine. And we are going to divide 2 to 16, 2 8 just 16, like this, and we can write the remainder quotient here directly also. Again 2 divides 48, again individually, here is comma also. 2 2 ja 4, 2 4 ja 8, like this. Now I think you are more clear about how to go away, how to go forward. Now again we can choose another number, 2 or maybe 3 also, no problem, if it divides at least one of the given number. Okay, and 2 6 ja 8, sorry, 2 6 ja 12, 2 9 ja, and 2 12 ja, and again we can choose another number, maybe 2 or 3, no problem, because if it divides at least one of the number, then we can choose that number. We may choose here 3 also, or any other numbers also. If we choose by 4, 4 3 ja 12, like that also we can go, no problem. But now we are choosing 2 2 3 ja 6. 2 divides 9 or not? No. If it is not divisible, you have to remember to write this number as it is. This is very important thing. And again 2 divides 12, 2 6 ja 12. Again we can choose by 2 also, because 2 can divide at least one of the given number, no? Otherwise we can choose 3 also, 3 1 ja 3, because it divides at least 2 numbers, so that it will be a little bit short. Okay, our solution will be a bit short, so that 3 3 ja 9, it divides 3 2 ja. Now is there any number which can divide at least 2 of the numbers here? No, no. If we choose 2, it divides this number only. If we choose 3, it divides this number only, so that it is not necessary to go through the division again. So we can stop here, and we can multiply these factors, all the factors, to find out the LCM. Okay, so our LCM will be 2 2 2, 3 times there, 2 2 2, again now 3, and here is 1, again 3 and 2, 3 and 2, like this we multiply. 2 2 ja 4, 2 ja 8, 3 ja 12, 12 1 ja 12, 12 3 ja 36, 36 2 ja 72, or we can do working in the rough side, okay, right side here, and find out the answer. This is, sorry, I think here is some mistake. Okay, I think it is not 72, I'm sorry. 2 2 ja 4, 2 ja 8, 3 ja 24. We can just like this also we can do 24 up to here, 1 3 ja 3, 2 ja 6, and 6 we can multiply. Okay, and so that we will get 144, so that our LCM is 144. Like this we can find out the LCM of the bigger numbers also by using division method. Okay, thank you.